x plus 2y equals 0, and 3x plus 2y equals negative 2. Decided to just make this one up on the spot. We'll see how it works out. It should be okay, though. So I want to solve this system. I don't know what the solution is. We'll find out. We're going to solve it using elimination. And I recommend, too, that maybe later on you try and solve this with substitution. It should never really matter which method you use. You should get the same answer as long as you do everything correctly. So just maybe in certain situations, one is easier in some sense than the other, but maybe, yeah. You have to get a feel for that. For now, let's just try and solve this with elimination. And so I've already lined up the equation for you. You know, the x's and the y's and all that are all lined up for us. So the next thing I need to do is pick a variable to cancel out and maybe multiply by some number to get the coefficients to be opposites. And so it doesn't matter. Maybe I'll turn it to you guys if someone wants to answer this. If we want to pick a variable to cancel and tell me what number I would have to multiply the equations by to set this up. Anyone want to hazard a try on that? No takers?
Didn't you hear? Can you hear me?
Yes, I can.
Oh yeah. So I said, can you just subtract, and that would get rid of the y?
Okay. So yes, yeah, you're basically right. Yeah, we could subtract if you want. And I always fuss about how I want to introduce this. If I want to talk about addition or subtraction, in the end, they're the same thing. It doesn't actually matter. So maybe that's a good. You guys should ponder this. Addition and subtraction are kind of the same thing, sort of. And I'll kind of explain what I mean. So yeah, you'll notice the y's have the same coefficient. The way I introduced it, it'd be great if they had opposites, opposite coefficients. So in some sense, I could subtract, because 2 minus 2 is 0, or what I could do is I could multiply maybe the second equation by negative 1. So I could take x plus 2y equals 0, and then I could multiply the second equation by negative 1, get negative 3x minus 2y equals, and then negative 2 is positive 2. Negatives cancel. And so now I have negative 2 and 2. They have opposite signs. And so if I add them together, it'll cancel out. And so the point is that adding a negative is the same thing as subtracting. Yeah. 2 minus 2 is the same thing as 2 plus negative 2. Those are the same thing. That's kind of what I mean when I say addition and subtraction are basically the same. Be a little careful with that. But so adding a negative is the same thing as subtracting the number. So I don't know. If it helps you guys to think of it as subtraction, you can. Or if you'd rather think of it as addition and you're going to multiply by a negative number, you can do that. It doesn't actually matter. Just be careful how you're working through it. I try to do it one way to not be so confusing, but anyway, this will work. So we multiplied the second equation by negative 1. So that just changes all the signs on each term down here. And now I'm going to add these two together. X minus 3x, x plus negative 3x, that's negative 2x. And then these guys cancel out. And then 0 plus 2 is 2. This marker is not the best. So I have negative 2x equals 2. Maybe I'll write this a little further to the left. Negative 2x equals 2. If you solve this out, divide both sides by negative 2, you'll get x is negative 1. X is negative 1. Okay. So I know the value that x has to be. It has to be negative 1. Now, once I know this, I can just go back into one of my equations and substitute x equals negative 1 and then solve for y, and I'll be done. So, I don't know, maybe this first equation, I could substitute x equals negative 1 up there. That'll give me negative 1 plus 2y equals 0. So I could solve this out. I'd probably add 1 to both sides, and then I'll have to divide by 2. So it looks like y equals 1/2. And so here's my solution. It's x is -1 and y is 1/2. So I can mention, if you didn't want to believe me, or if I wanted to check my work, that this was correct, you could take -1 for x and 1/2 for y, and you could plug them in back up here into each of these and see that it works. So this is a good way to check your work. If you get to the end and you get an answer and you're not sure if it was correct or not, take your answer and plug it back in and see if it solves the equations or not. If it solves them, then you're good. And if it doesn't solve them, then you made a mistake. You need to go back and check. So that's just something to keep in mind. That's handy. You can check your own work. Okay.
I have a quick question.
Yes.
So in this case, we already had a variable with the same coefficient, and we just had to make them opposites. But if we didn't have the same value there, we'd have to make them opposites, but also the same coefficient, right?
Yes.
Okay.
And so, actually, so you could do this problem in a different way. Maybe I wanted to cancel the x instead. And here the coefficients of the x's don't match. I have 1 and I have 3 are my coefficients. So maybe then to make that work, I could multiply this first equation by -3 instead.
Okay.
And then the x's would have opposite coefficients.
Okay, thanks.
Yeah, no problem. Anyone else have any questions? Okay. So that's pretty much how elimination works. And of course, the best way to learn this stuff is to practice. So you guys are going to practice all of this on your activity and on the web work as well. I'll put up the web work assignment for section 2 today. It'll be due Sunday, I think. Anyway, you'll see that on web work later. But the best way to learn this is by practicing. And so unless you guys want to see another example, I think it's a good time to just start work on the activity to get you guys starting to work with it. So I don't know. Does anyone have any questions, or do you guys really want to see another example? Okay, so I'm going to take that as a no.